Let's look at number 32. And number 32 is y plus 3 equals 4. If you're working on your own, you're good. But there will be times where I'll say, all right, please listen up because I want to get everyone's attention so that you'll know what to do even on your own. But that's going to come up. Let's see if you guys can figure it out. Everyone's attention. Everyone's attention. So they're like, la, 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 la. Or, please listen. I want to help you. There you go. There you go. If you have an equation with only a y or only an x, so it doesn't have the x and the y, it's going to be either vertical or horizontal. Do you understand? And you don't have to make a table. So what about this one? Does it have one variable? So you don't need to make a table. But you do need to solve for that variable. So how do I solve for y? And let me make sure I wrote the right thing. Okay. You subtract 3 from both sides. Is that what you get? Y equals 1. So solve for that variable, whether it's x or y. In this case, it's y. Okay. All right. You don't have to make a table. And you're like, then what do we do to graph it? Okay. First of all, go ahead and get your graph set up. This is how easy these ones are. And you realize y equals something there, and I'll put here just to, if you need notes or to remember this for later on, one variable. It's a type of vertical or horizontal line. Does anyone remember which one it is? Horizontal or vertical? Maggie? It is a horizontal. All right, do you see where y equals 1 right there? And you can make a little tick. Y equals 1 right here, so this line is going to go through that infinitely. That's it. That's your graph. You're done. So does y always equal 1 no matter what point you pick here? Yeah, and you're like, I don't think so. So I'm just going to test it out. Let's say this is x equals 3. This is y equals 1. What are the coordinates of this point? 3, 1. What does y equal? 1. Does y always equal 1 on this line? And the answer is yes, you're done. 32 is complete. There's one other where there's one variable, but it won't be y. It'll be x. So what kind of line is it? Vertical line. So don't forget that, please. If you move ahead of me, go ahead, but don't forget that. Don't ask, Mr. A, what if there's an x, only an x? I will not answer that question. Okay. 36, so that one's a more difficult one. I've changed what I want to do with you guys on the table. I want you to pick 3 values. 3 values. 0, a positive, and a negative. You must pick those. You must pick 0, and you must pick a positive and a negative. I don't care which positive or negative, but hopefully you pick a good one.
We were supposed to do 4 yesterday.
4 yesterday. That's okay. Thank you for letting me know. Okay, number 36. We have 6x equals 24 minus 6y. Okay, so does this only have one variable? No, it has 2 variables, so you got to make your table. But before I even start making my table, what do I have to solve for? Now, I don't have a choice. I have to solve for this variable, y. Solve for y. Get y by itself. So it's being multiplied by negative 6 and added with 24. So what do I deal with? Subtract 24 from both sides. Because that'll get rid of that. You're left with, and you can put this many ways, but I'm going to put 6x minus 24 equals negative 6y. That negative 6 did not go away. It's still negative. Then what do you divide both sides by? Divide both sides by negative 6, and a lot of you are showing it well. And that's how you show it. I'm asking this question because this will help you out in future problems. Can I divide 6 and 24 by 6 evenly? Is that possible? Then I will do that. So 6x divided by negative 6 is negative 1x, or negative x. You guys, right here. And you know what? Maybe some of you can see better. With a nice puree, mango puree, or old avocado yellow. How about that? Okay. Do you guys see how this gets me this? All right. And then I have to simplify this as well. So what's negative 24 divided by negative 6? Positive or negative? Positive. Positive 4. What's left on the right? Y, right? Because the negative 6's got canceled. Am I rated? Yeah. Say that again? No, because here the negative is x and here the positive is 4. And if you did what you said, now the 4 is negative and the x is positive, so it changes it. So yeah, be careful with that. Okay, now do we have enough to make our table? Yeah, because now we have what y equals. Go ahead and make your table. 3 values. And I'm going to ask somebody for their values. I'm going to make it big, by the way. Even if I only have 3 values, the bigger I make these rows, the more space I have to work with. Say that again? Oh, okay. What value must you pick? 0. So I'll put that right in the middle. And then 1 negative, 1 positive. You must do 0. Okay. Doesn't matter what you pick for x. What do you think on this one? Is it really going to make it harder if you pick 1 or 4? No, so just pick your... I want you guys to pick different numbers. I'm not going to give you the number. I want you to pick it. Pick numbers. 1 positive, 1 negative. You're on your own. You pick it. And then I'll pick mine. Pick yours. Because we have to get the same answers. We must. If we do it correctly. Okay, so I select mine. I'll go with positive 2 and negative 3. Did anyone pick those?
I picked positive 2.
Sorry?
I picked positive 2.
Positive 2. Oh, yeah. 2, but not negative 3. Okay, so this is what you have to do now. This is my x, this is my y, this is my x comma y, and this is negative x plus 4. And that, I hope you guys know. So just substitute your x's in every one, and you got to be careful on this, especially with more complicated problems. You see what I'm doing here? Instead of the variable, I put parentheses, and then that negative sign is outside of them. So what's the opposite of 2? Negative 2. Negative 2 plus 4? Okay. Did anyone pick 2, by the way? Anyone pick positive 2? Brian did. Rosalind? Lily? Okay. Some of you picked 1. That's cool. You would have gotten 3. All right, but you all picked 0, so what do we get for y? 4. Because negative 0 is a 0, plus 4 is 4. Did anyone pick negative 3? I'm all alone in that. All right. What's the opposite of negative 3? Positive 3 plus 4, 7. That's my number. So none of you should get negative 3, positive 7, right? Because you didn't pick negative 3. But it should be possible to get it on your graph. Go ahead and get your ordered pairs. And put it on your coordinate. Oh, actually, I'll just do it right here. Before I do that, let's talk about it. What do you guys think? What should be my x scale, my y scale? Okay, let's go with the x. Do I have to go wide? No, because I'm going from 2 to negative 3, so not super wide. What about my y scale? I don't have to make it super wide, and do I even have to put anything in the negative side? No, I'm going to do this. Oh my. It's like a sword. Okay, go ahead and put your tick marks. You can go by 1s, or you can go by 2s. I don't mind going by 1s on this one. Maggie, did you have a question?
When I did mine, I did the x coordinates as negative 1, 0, and 1.
Negative 1, 0, and 1. Uh-huh.
And then when I graphed it, it went like that.
So what I would do is make sure that you did this work correct, because that's where the mistake is.
At 1 point, I worked it all like 5 times.
5 times. Only do it the 6th time. No, let me. Can I do this and see if we work it out? Okay. Let me get here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that line is so crooked, but that's okay. I don't have graph paper. 2, 2. Let me get 2, 2 here. 1, 2, 1, 2. 0, 4. 1, 2, 3, 4. And negative 3, 7. Oh, my. What's wrong with this? Because I'm getting the same thing. Oh, no, wait. No, I'm not. Negative 3, 7. Wow, I was starting to give up too easily. 1, 2, 3, 4, 5, 6, 7. Somewhere right there.
I didn't get that. I got one to go like this.
So, give me your domain value, your first one. 0 we got, right? You got 0, 4? Okay, give me another one.
Negative 1.
Okay, the opposite of negative 1 is positive 1 plus 4. You should get negative 1, 5. All right, give me the other domain value. 1. So negative 1 plus 4 is 3. So 1, 3.
I did the same. I did like. Oh.
Yeah, and that's okay. I'm glad we found it. That's okay. Yep.
Is it supposed to do that? Like.
No, it's supposed to be a line.
Where does it go?
So listen, if you are not getting a line, wasn't this a linear equation? So can anyone give me a point that they got that was not mine? Did anyone get a different point? Because I want to see if this works. Jack, give me a point.
I got negative 4 and 5.
1, 2, 3, 4, 5. Right here? Does that fit my line? That fits. Give me another point.
2, 2.
Oh, yeah, I got 2, 2. We both had that, Brian.
Negative 2.
Negative 2, 1, 2, 1, 2, 3, 4, 5, 6. Does that fit my line? And I know mine is all crooked and stuff, but it would be a line. Do your points fit my line? If you did them correctly, we got them right. So do you see how that works? How many of you got a line? Oh, mine. That almost did it. How many of you got a line that looks something like that? Okay. That's okay. If you didn't get it the first time, we'll work on it again. Number 37. How's your table look? What? Why? There's only an x. So what did x equal in number 37 for you? Yep, so it's 37. Some of you have x equals 7 halves, and some of you have x equals 3.5. That can't be. They're not the same. Oh, okay, fine. So you're done. They're both the same. 3.5 or 3.5. And you don't need a table. But what kind of line is that one? If x equals something, vertical, wherever x equals 1, 2, 3, 4, right there, you're going to make your vertical line, and you are complete with that. Or you are done with that problem. You see that? Those are nice. Don't worry, guys. You won't get any more of those on this. Oh, time out. There's one more. Oh, man. Do you know which one it is? Okay, fine. All right, so 42 will be another vertical or horizontal line. Oh, sorry. You guys know. You'll figure it out. Yes, ma'am?
What? You said we should do 32 through
I have it up there. 38. Okay, from here on out, I will not graph these. I'm just going to help you get the equation and numbers that you can put as a domain. So let's look at 38. 3x minus 4y equals 60. All right. Is that how I want it? Bummer. What do? What do I solve for? Solve for y. So then, all right, y is being multiplied by negative 4 and added with 3x. Subtract your 3x. These are not like terms. So I get negative 4y equals 60 minus 3x. You could have also said negative 3x plus 60. Either way, it works out. Then what do? Divide by negative 4. And I'm left with y equals. Now, look at this little part right here. Do both of these, do both 60 and negative 3 divide by 4 evenly? Does one of them divide evenly?
Yes.
Okay, you have a choice. You can leave it like this and put in your x values. I wouldn't recommend that. Or you can still divide it out and deal with this fraction. And I'm going to do that second method. What's 60 divided by negative 4? So what's 60 divided by negative 4? Negative 15. And then what's negative 3x divided by negative 4? It's positive 3/4 x. Or you could say positive 3x over 4. It's the same thing. Okay. I'm not going to help you with the graph, but I am going to help you with some values to pick. What value must you always pick? 0 is nice. Just use it. It's good. It's one out of the 3. You're already done. But now which values am I going to use for x, positive and negative? 4. And? Negative 4. You're done with that. Like, now you can work it out and figure it out. Because what happens with those 4s when you put in 4 for x? They cancel. What happens with the negative 4? It also cancels. Can you use 8? Can you use 12? 16? 20? Okay. Can you use 21? That's a trick question. Can you use 21? Yes. You're just making life really hard for yourself. Okay. So go ahead. You can use that one. I'll give you about 4 minutes, and then I'll go to the next problem. If you're already done, keep going on your own. Yes, ma'am? Oh, let me pause this here. Okay, go ahead.
What did you say? I was confused.
That's okay. Any number that's a multiple of 4. So like 4 and negative 4.
Okay. Do we have to use 0?
You must use 0. And it's the easiest one to use. Trust me.
Okay, and we have to do a negative. Right?
And a positive. Mm-hmm.
When you divide negative 4 by, or times, multiply negative 4 by 4, it'd be negative.
Let me show you here, because it's hard to like picture that out. Are you using all this side?
I was going to do that.
Okay. So let me write this down here. It's going to be negative 15 plus 3/4 times 4, right?
Yeah.
So I write it out, and you might maybe make it like a table that's bigger, or you can see it. But what happens to these 4s?
They cancel out.
So you're left with negative 15 plus 3, which is negative 12. Okay, and you're looking at this one. So now here, if you write it big enough, it'll help you out. Because sometimes those signs are hard to see. 4, negative 4. Okay. So the 4s cancel out, right?
Yeah.
Did the negative cancel out?
No.
So what's 3 times negative, and there's a 1 here. So what's 3 times negative 1?
Negative 3.
So it's negative 15 plus negative 3, which is...
Negative 15.
Yeah. Yes.
Okay, this one, so like I know that this cancel out, so would that be negative 1 and then a 3?
Mm-hmm. So
So
3 times negative 1
is negative 3.
So negative 15
So
plus
negative 18.
Yeah.
And then would this one down here be negative 12?
Yeah. Yes, ma'am.
So why would it be negative 15 and 3/4?
Oh, and what I would say here on is for x, I would pick multiples of 4. Because, yeah, you would get negative 3/4, but then that's hard to add with that. So try 4 and negative 4. Good.
I just don't know
This one right here. So now you need to make a table, and you need to pick values for x. What's the value I always want you to pick? 0. And then now I have to think, all right, what other numbers should work? If you have a fraction here, you want to pick a number that's a multiple of the denominator. So like, yes, ma'am.
For this one, would it be negative 3? Negative 4 and 3/4?
Yeah, can I see your pencil? I'll show you what happens. Like, what happens to this 4 and that 4?
They'll cancel.
And they become 1 over 1, right? So, what's 3 times negative, or sorry, is that a negative 4? Yeah, what's 3 times negative 1? now?
-3.
So it's negative 15 plus negative 3.
-18.
Yeah.
I can get it in here.
Sorry. This one?
Yes.
It's a line, and it fits. It looks all right. It's a good line. Good straight line. Okay. I'll give you about another minute, and what I'm going to require, if you want to follow me, maybe you're already done with your graph or you're not. I would say stop with the problem you're at if you're not there. Sorry, if you're not complete. And then you can go back to it later because I'm going to help you out with the next equations because those are the tough ones. Um, 39. I think it's 4x minus 3/8 y equals 1. Did anyone graph this one already, 39? Anyone make a table for 39? You made it? Are you almost done, or?
No, I made a table, but I just didn't know what to do. I just like my numbers.
This is one of the hardest ones for making a table, so I'm going to help you out with that. So don't get ahead of me on 39. Stay with me. All right, do I use this form? No. I got to get y by itself, so what do I do? Raise your hand and tell me what to do. It's okay, it's tracking that. There you go. Emery? Subtract 4x from both sides. And you're left with negative 3/8 y equals 1 minus 4x. Or negative 4x plus 1. Same idea. And then this is a tricky part. You could get rid of the negative 3/8 by dividing both sides by negative 3/8 or by multiplying by negative 8/3. So I'm going to multiply both sides by negative 8/3. Because doesn't that get rid of the negative 3/8? Yeah, so you're done with all that. You're left with y on the left, which is good. But you must be careful on the right. I have to multiply everything by negative 8/3. What property is being used right here to multiply it? Distributive. So you got to do what's 1 times negative 8/3? Negative 8/3. What's negative 4x times negative 8/3? Positive 32/3 x. Ooh. Okay. So now I want you guys to talk to me about what numbers you would pick. Talk to me.
4.
3. Why?
Because it would cancel a denominator.
Would 3 cancel out this denominator? Yep. Would it cancel that one out?
Yeah.
But, sorry, it would not cancel this one out. It would cancel that. That's your best bet. Like, you just go with that. Anything else? That's a good number. 3. Try it. Negative 6. Would that cancel this 3 out? You could deal with that. And then you have a negative. You're going to do negative 8/3 times that negative 64, I think you'll get. Yes, but not this one. Okay, you're done with this problem. I'm not going to make you waste your time on this. Not wasting time, but just, did anyone do a table and start putting values in?
Wait, we don't have to do a table.
Okay, let's just do 1. I just want you to get practice with 1, and then you're not going to draw a line. I want you to pick your value, and I don't care what it was, but it should be a multiple of 3. So 3, 6, 9, negative 3, negative 6, negative 9. Pick it. You pick it, and I want you to solve for y just once.
Just one? Just like
Yes, just once. Not 0. Because we would know if that's 0, y is going to equal negative 8/3, that's why I like 0. But Yeah, just pick one value for x other than 0. I'll go with -3. I'm going to pick -3. Because I want to. You could do +3, you could do -3, positive. I'm going to pick -3. Okay, what happens with these 3's? Cancel out. And I'm left with what over here? I think I heard it. -32. I get y equals -8/3 minus 32. Okay, and you're like, whoa, what do I do? Can you combine these two fractions with addition? Right now, you cannot. And you're like, what fraction? This fraction. So what do you have to get? Common denominators. What's the common denominator between these two? 3. So you got to multiply this by 3/3, which is just multiplying it by 1. Yeah, so you'll get -8/3. So that first fraction minus 96/3. And can you add those two together? Yeah, you'll get -104/3. What does that even mean? I don't know what it means unless I can change it to a mixed number or a decimal. So I'm going to look at this 104 divided by 3, and that's 3, 9, 1, 4, 4, 12, 2. So it's -34 2/3. You see why I'm not going to make you graph it? Unless you want to. You're more than welcome. So what's my ordered pair, and then we're done.
-3 and 34 and 2/3. -34.
Oops, I wrote it wrong. That would be my ordered pair. Can you graph that, though? We haven't done that. Can you graph it? Yes, you can graph it, but we're not going to do it. Okay, so you're done with 39. You guys getting this stuff? I mean, does it take a long time to do that problem? Yeah, but is it possible? I need to make a note here. Sorry? Yeah, solving. And this is a tough one. I need to make a note here. You can keep working, kind of listen as you're working on the next one. Hopefully you can at least solve for y, even with decimals. But actually, Mr. Hubbard shared a video with me about the title of it is Stop Telling Them They're No Good at Math. I'm like, what is that? So I clicked the video. It was only 3 minutes. Nice video. I might show it to you sometime. But it's basically this. How many of you think that the ability to do math is something that is innate? That means that's inside a person or it's not inside a person. Like either you have the ability or you don't. How many of you do? Okay. How many of you think math is just like something you're born with? Like the ability to do math is inborn. Okay. I think a lot of people think that. Excuse me. It's actually not. They've done so many studies now that it's not true. How many of you know how to speak French? Kind of? Okay. Now, let me get personal. How many of you know how to speak Spanish? Now, how many of you, let's say 2 or 3 years ago, knew how to speak Spanish? 2 or 3 years ago. How many of you, after 2 or 3 years, now know how to speak Spanish? Listen. Ready? Some of you know how to speak Spanish because you learned it earlier. And some of you know how to speak Spanish because you paid attention. But some of you were, neither of the groups were like, yeah, we just know, I just grew up Spanish. That's not how it works. Spanish is a learned language just like English, French, and all the other ones. You know what math is? It's a learned language. You either practice it or you don't. If you don't practice it, guess what happens? You don't learn it. If you do practice it, well, guess what happens? You learn it. It's amazing. Some people are better at languages or better at math or science, but it doesn't mean you can't get better. And I've seen it. You know what? What's kind of cool? I've seen it in you guys. I've seen some of you who came and last year and you didn't know how to do math. Like that was what I got. You don't know how to do math. I'm like, what? Really? They know how to do math to me.
What happens if I still don't know how to do math?
Then practice. If you don't practice, you won't get better. I know. It's kind of like sports, skills, music, language, and everything else in life. You don't practice, you don't get better. LeBron James practiced. As good as he is, he practiced. He practiced. Yeah. That rant was taken out of context. But anyway, he did practice. As a young guy, he practiced. And he practiced a lot. Some of you are going to get better at math because you're going to practice. And some of you might not because you won't practice. There's a difference. Yeah, so something happened. Let me see here. Okay. Here is number 40, and I hope that's it. Your whole goal in this problem is to get y by itself. And it's decimal. So now you give up because you have decimal. No, don't give up. Just okay, nice. That's a good perspective. It's a fresh perspective. So you get your 5y. And you can go 7.5 minus 2.5x. Then you divide both sides by 5, which means, don't forget, you got to do this by 5 and this part by 5. And you should get y equals 1.5 minus 0.5x. Is that what you guys got? Okay. So on this one, what are some good numbers to pick? There are actually better numbers than others. Like, I don't know. They're not even... Okay, you could go 1, 0, and 1. That's a good set. Any others?
It's -4, 0, and 6.
Okay, so why'd you pick 6?
Well, because if you do 16 minus 6, it's 10. 10 is a multiple.
Okay, if I agree with 6. 6 is good because what's 6 times 0.5? Or what's half of 6? 3. So 1.5 minus 3, negative 1.5. So that's easy to get. And then 1 is even easier because what's 0.5 times 1? Don't be shy. 0.5. What's 1.5 minus 0.5? So you should get 1, 1. 1, 1 is good. What about 0? 0, 1.5. And then I think negative 1 is a good one. You get negative 1 times 0.5 is positive 0.5. You get negative 1?
Never mind. I was looking at a different problem.
Okay. So you should get those numbers, and those are nice to graph, right? I hope.
I had those same points, but it didn't graph right.
Okay. I'm going to sketch it. I'm not going to do it exact. 1, 1, 0, 1.5,
Yeah, mine's like all.
and negative 1, 2.
Wait.
So ready? 1, 1. 0, 1.5. Negative 1, 2. I sketched it. I did not draw it exactly.
I got that.
It's a line. You got it?
Or they use the exact same one.
That's okay. Yeah, but you should get this shape and this slant.
Oh, I graphed 0.5 instead of 1.5.
Negative half of 2.
Wait, where did you get 1.5?
Negative 1. 0. This one right here.
No, the equation. I got mine that looks like that, but I got the 2.5 minus.
Oh, what's 7.5 divided by 5? No, just put 1.5 and put them back in. All right. I think those are good. I'm going to give you help on one more. And if you understand what I did on that one, then you should be able to get the other two. Numbers 43.
Yes, thank you. No, shoot.
No. That's your homework. But let me help you at 43 real quick. Listen, 43. Last help I can give you.
Wait, is
You
that
see,
odd?
Do you see how you have denominators of 3 and 4? Get rid of those denominators by multiplying both sides by 12. Multiply both sides by 12. You no longer have fractions. Do that for number 44 and 45. Multiply by a number that will get rid of your fractions. All right, you guys can go. You're welcome.